the demo.
Okay. Morning, everybody. I'm Luca Fabri. I work with Aureliana. I was involved in the development of the front end part of the transformation framework. I'm trying to I hope you can see my screen. Okay. Yes. So this demo will cover the integration of the transformation framework behind an authorization layer. In our example, we will use Keycloak, which is the default supported software. But we are based on well-known standard, which is OpenID Connect. So I will not be surprised if this will work with any other OpenID Connect compliant software, but this is untested. So the transformation framework is provided with no mandatory authentication layer, so it is freely usable. But it's quite easy to enable an integration with an authorization layer. This is done with a dedicated section in the main configuration file. With a big, let's say, green button here, a flag that can enable or disable quickly the integration. When we activate the integration, obviously we have to provide also many other information like the service URL and some other internal information we will not detail, but this is a standard OpenID Connect terminology. Okay, so I have locally a transformation framework instance running, and the flow is like the following. We have a user on the network that is trying to reach the transformation framework. The transformation framework is not providing any user interface, so is just an API on the web, which can be accessed using curl, Postman, or whatever you will like to use. When the authorization layer is enabled, every request sent from the user should provide an authorization header, the bearer header, which contain an access token. The access token is an alphanumeric string with no meaning for a human. Inside the transformation framework, which is this big block here, we have a proxy. This proxy is the one that tries to validate the access token provided by triggering a sub request to the Keycloak instance. The Keycloak instance, following the OpenID Connect standard, we reply with a status code, which is the most important information for us, because an error status code will mean user is disallowed to access the transformation framework, or a success code with some JSON information attached. If the authorization is successful, the request is then routed to the real, let's say, OData API in the upstream of the Nginx proxy. So as I said, when the keylog integration is active, we can't reach the transformation framework without providing this access token. So in this example, I'm trying to reach my local transformation framework instance with one of the many routes provided. This is the one that returns me the list of my transformation, and I will get back an error. A 401 error is a standard error that means you have to log in. Okay, now the question is how can I obtain this access token? This is quite something that is out of the scope of the transformation framework itself. So let's say it's just a communication from the user to the keylog directly. This is something that must be documented, but can fit in this demo. So I am using a black box utility function that authorizes me as a user. In this example, I'm authenticated as a EVV user, which is a user registered on the keylog instance. Okay, when I ask to the keylog, when I authenticate on the keylog, I get back this very long string, which is the access token I introduced above, and also, but just for debugging purpose, I printed this here. Some other information about the user, like email, given name, and so on. These are very interesting information to be used, but to be GDPR compliant, we are not using any of them, but the SUB. SUB is a very low level user ID, which help us to keep the privacy of the user under control. So we can log this information in our application log, in Nginx access log, without worrying about deleting log files later if the user asks to be removed. Okay, this is for GDPR. So now I have this access token that help me to be authenticated as a user, as a well-known user. I can repeat the same operation by providing this header. And now I have back a response with the success code. Okay, the response I received is a list of my transformation. As you can see, I have already a completed transformation in my queue, which I prepared before this demo to speed up things. What is also important to note is that this information, I hope you can still see the other window. I move it to a shell. Can you confirm? Yes?
Yes. Yes.
Oh, okay. So information about the user are logged on every file. For example, we registered that the user with this ID required the list of transformation, and at the same time we have the internal internal Nginx access log, where we are storing every request to the transformation framework. My first request without the access token was a 401 error, so I was not authorized to access, and I have no information about the user. My last request succeeded, and I have the information about the user also in the standard HTTP access log. Okay. Now, using the same access token, which can be reused until it expires, and when it expires is just a matter of configuration of the keycloak instance, so not under the control of the transformation framework. I can submit a new customization using the standard API. Oh, okay. I got back information about the new transformation, and now if I ask the list of my transformation, I got back 2 items. So I have the old transformation already completed, as you can see here, and also the new transformation up above, which is still in progress. Now, one of the main features introduced when you activate the authentication integration is about the ownership of the transformation. So every user can only see normally transformation he owns. So transformation he ran before. So if I authenticate using again this utility function as a new user, which is called tf-test01, I will get back a different user information and a different access token. So when I use this new access token, which is saved in this manager user token here, I am a totally different user. This because we are not using cookies, so this is a stateless protocol. Okay. So if as this new user I ask for my transformation, I will get back an empty list because I have no transformation running or completed for this user. But this user, as you can see here, is also profiled as a quota manager. Quota manager is a keycloak role, but is configured to profile this user as a manager. This is done in a different configuration file, but it's quite easy to understand. Here we are saying that a user that have the quota manager role from this keycloak client is profiled as a manager. Okay, a manager is just can be just a normal user, but you have also access to a protected root that is prefixed with /admin, which returns every transformation from every user in the system. So here, as a manager user, I can access this root and see transformation also from the first user we introduced above. Last, another feature we can control with the authorization, and also with this configuration file we have seen before, is quota management. When a user reaches his configured quota, any other transformation will be discarded. The quota management works this way. We have a configuration file where we can define a general rule, like in this case we are saying that normal user, let's say, can only have one single running transformation, and we can then tune up this number, saying that other user with different roles can have a different quota. So if I try, for example, to submit a new transformation with the first user we logged in above, I got back an error. Why? Because this user have still a transformation running, and the overflow is quota. Last, we have access to the download route. The download route is something that is managed directly from the Nginx. So if we go back to our schema above, the download route will not reach the OData API, but it's just something done by the proxy here. But still, access to the download is protected by keycloak in this case. So if, for example, I provide a wrong access token here, I got back an error, while using a valid access token. As you can see, it is taking some time because it is downloading the file. And that's all. If you have any question, you're welcome. No? Okay. I can stop sharing my screen.
Okay. So now I share my screen. Just a moment. Now we are going to see an example of transformation framework external workflow. We have already seen how to implement a workflow, a new plugin, but I want to recap a little bit the main steps. Well, each workflow shall be contained in a Python package that shall implement a processing function that executes a processing or wrap an external library. Okay. Then must define the workflow configuration that is a dictionary where declare its interface, and then the workflow configuration must be defined as an entry point in the package package setup. Now this is an example of processing function, and you can find this test plugin here in this repository. As you can see here, we have this is a standard Python package. Here we have init, here the workflow that implements a very easy function, because it just take the input and copy it in the output path and return the output path, product path. And then here there is the description of the workflow, where you can see here we have some parameter that must be defined, some key that must be defined, and also the workflow options that will be used for that will be exposed to the user, because it defines the workflow interface, and it will be also used by the transformation framework to define to check the input from the users. Now, I want to I just want to add something about the log. Currently, the transformation framework define the Python root login in a specific way. We have the transformation framework version, the logger name, the order ID, the datetime, the logging level, and then the log message. If the workflow, if the plugin will use the Python logger, then it will generate automatically the login format of the transformation framework. So usually when you instantiate the logger, usually is used something like that name. But in this case, it would be better to use the plugin name, so it would be easier to recognize the error from the plugin in the log. Now this is the workflow description, and now I will show you here in GitHub. We can the plugin, the workflow description is declared inside the configuration in this way. You can declare it inside the setup.cfg or in setup.py, but it's the same. Okay. Now let's see how to install it. First of all, okay, for installing a new plugin, is really very easy, because all you have to do is to copy the source code or the wheel inside the SATF plugins directory. Now the directory is empty, and okay, the transformation framework is already running. So if I try to ask for the workflow available here with request, I obtain only send to core. Now, okay, here, just to be sure that it's empty. Now I downloaded the test plugin from GitHub and then unzip it in the plugins directory. Okay. Okay, now in the directory we can find the plugin. To install it, we have to turn off the transformation framework and turn on it again, because it is installed by Docker Compose. So make down. It's installed by Docker Compose on the container. It takes few seconds. Okay, make up, and now we should see that it is installing the plugin. Here. Oh, it's here. Okay, so if we ask for the list of workflow, now we obtain also as a test plugin. I just want to check that it's really working. So now I define some parameters, and I submit the transformation, and we obtain the response, and the status is in progress. Okay. Now I just want to show you that the workflow description that it was for the workflow description. It is used to validate the input parameters from the user. For example, in this situation, here we have the option parameter 1 should be an integer, but here we try to use a boolean. So if I try to submit it, the transformation framework writes an error without submitting the transformation. Okay, the last thing that I want to show you is that the transformation framework validates the workflow description that the plugin provides. For example, let's go to code here. If I, sorry. If I remove, for example, execute here, and I try to reinstall it, you will see that the transformation, the plugin is installed, but doesn't appear in the list of the available workflows. It takes some seconds. Okay. Okay. It will take some time because it's still running. It's still installing. Okay. Here we have only send to core, and our test plugin is no more available. And here the transformation framework writes an error. So you know that that execute is missing, and that's why the transformation framework is not loading the plugin, the workflow. I think that's all. Okay. If you have some question, I'm here.
No one.
No, could I ask a question?
Okay.
Better or Eliane? Yeah, we've been talking about trying to integrate our own sort of workflow with. There are a series of Python processes. So would you have? We talked about maybe having a bash script that would sort of call the Python processes, but from what you've outlined, would you have a Python wrapper package, a workflow package that would then call the different Python components in the transformation framework? In other words, it's not just one process, it's multiple processes that run in a series that you wish to integrate?
Okay, please, okay, the audio is not very good, so could you repeat, please, because
Sorry.
I think I'm missing something. Sorry.
Okay, sorry. No, so the context I'm talking about trying to set up a new plugin for the transformation framework. So we have a new workflow that we look to implement. But that workflow is not just one process, it's a series of processing steps. So the output from the first one is the input to the next. So how would you write a wrapper Python module that would then be called, or and so sort of?
Okay. Currently, we don't support a series of processing concatenated. So probably you have to configure only one process for this version.
But internally, that process that you call could be doing multiple sort of processes.
But are you talking about multiple processing concatenated? First,
the same data, yeah. So some input data, you do some you do some processing on it, and then some more processing.
It shouldn't be a problem, but you have to manage this on your side, because all I do is calling your function, just that, and you have a processing directory where you can do everything. You have your space, and then you return the output, and that's all. So in the middle, you can do whatever you want.
Right,
but you have to do it. Yeah.
I see internally. Thank you.
Yeah. Okay, I just want adding a few stuff that probably in the next release we will change a little bit the interface, because the integration with the traceability, for the integration with the traceability, we will probably need some more some information from the plugin for generating the trace. Just this, but very few changes.
Aureliana, if I may add one point on the question from Stephen, if I remember well, from a few moments ago. You will find Stephen in development guideline indeed in the document that is attached to the release. So you'll find all the steps that you can do to create the plugin. So really following what we saw a few moments ago. If maybe by reading what is reported there, you come out with some other questions or any point that we can clarify, or I mean, any doubt that we can support solving for your use case, the one that you were mentioning, let us know, and we can support you, guide you, let's say, in the generation of the plugin as much as we can.
Oh, thank you, Elisabetta.
Yes, indeed, and probably most of you already know it, but this version of the transformation framework is available via Jira in the AGR 18 with all the relevant documentation, as Barbara explained. Okay. I don't know if there are some other questions or not. If not, I think that from our side it's all.
We can proceed with the presentation of the evolution of the HS3.
Yes, thank you.
Okay. Okay. Okay, so for what concerns the HS3 milestone, the evolution of the transformation framework that is currently planned is the interface integration between the transformation framework and the traceability service of ESA. That is a service that records and verifies the authenticity of Copernicus Sentinel data throughout the entire life cycle. These are the documents that explain in details what concern the traceability service, so the user manual, a technical note, and the interface control document. This sequence diagram depicts what we have seen for the DHS2 and the new enhancement for the DHS3. So a user choose a workflow and submit a specific request for transformation on an input product. The process will end with an output product that is put in a staging area. And so far, until now in the DHS2, the user is able to download the output product thanks to a download link that is returned to the user. In parallel, what we are going to implement for DHS3 is, as anticipated by Aureliana, the generation and the sending of a trace towards the traceability service. A trace is a JSON containing a set of metadata of information for a product. So this trace will be generated for each output product of a transformation and will be sent to the traceability service and stored in its DB in order to allow users to search and check the metadata of this trace, of this JSON. What will be mandatory for collaborative users is to request to ISA a set of key elements in order to be able to send a trace to the traceability service. So the key elements to be requested are the credentials to access the traceability service, a private key, and a passphrase for signing. How to request these elements is described in procedures stated in the documentation we show in the first table. What will be implemented on the transformation framework side is the integration, so the usage of the trace tool of GAEL to generate the trace, and the updating of the transformation framework in order to include a sender subcomponent to send the trace towards the traceability service, and also to upgrade the transformation framework in order to allow the administrator to activate or deactivate the interface with the traceability service for each workflow process. So this will be the main enhancement for the DHS3, and it will allow to have a clear trace stating the authenticity of the Copernicus data produced by the transformation framework, also stored in the traceability service. Okay. So we will see this enhancement in a future live demo for the DHS3, I guess.
Yes, grazie Fede for this last set of information. Just to give you a more detailed overview of the timeline that we have in mind. So we plan to deliver to this community, the DHS3 with the interface with the traceability service around July this year. So it's for now the last release that we have in plan. Then of course, it will be up to ISA to define the plan for the future of this. And since many of you have in plan to work on processing pipelines or anyway processing functions, when you start the work or anyway you are planning to start it, let us know if you find that there would be some features that you would like to see in the transformation framework, because it's it's important to us to know what is needed for your operations so that we can put this in a pipeline, so we can plan the implementation of the features necessary for you.
Okay, thank you to all. If there are not other questions, I think that from our side it's all. And I just want to underline that I am available for any question and apps offline, so via email or via Jira. So do not hesitate to contact me for any needs. And I will upload the registration as well in the relevant issue. And okay, for me, it's all. Just as further information, we are also planning the demo for the other delivered component that is Daphne. So I will inform you very soon for this new demo.
Thank you.
Thank you, everyone.
Bye-bye.
Bye.
Have a good day.
Thank you. Bye-bye.
Bye.
Bye. Bye-bye.
Thank you. Bye.
Thank you.
Bye.
Bye.